All right, here's all the answers for the your turn ionic naming in your note guide. We'll do this first column going from the formula to the name first. We did that for practice the last video, and here are your answers for these. Name your first element, iron, and your second one right here, this is a polyatomic ion. You're going to find those on your polyatomic ions reference table, and we're looking for C2O4. Here it is, oxalate. So this would be iron oxalate. The last thing you want to ask yourself anytime you're naming, can the first element or metal have more than one charge? And you're mainly looking at D block elements for those. Iron is a D block element. It can have more than one charge. If you look at your fancy periodic table, at the bottom of the box for iron on your periodic table, you will find a list of possible charges for iron. They call them oxidation numbers, and iron can have more than one. It's +2 and +3 is what you'll find there. So we need to figure out the charge of this. On your polyatomic ions reference table, this whole side right here collectively will have a -2 charge, and that means our single iron right here must have a +2 charge, and so we're going to call this iron 2 oxalate. Our next one will be magnesium and oxygen. That's magnesium oxide. No need for a Roman numeral. Magnesium is a group 2 metal, and it always makes a +2 charge. It's not one of our D block elements. This is manganese, not magnesium. Manganese oxide. Manganese is a D block element, so it needs to have the charge written in its formula. This is manganese 2 oxide. And to give you an idea of why they put this in the formula, manganese can also have a +3 charge or a +4 charge and some other charges as well. Let's do the +3 version of this though. Manganese oxide with a +3 charge would look like this. And we would write this manganese 3 oxide. How would I figure out the charge from that? On this side we have 2 manganese. I'm going to write this out. Let's squeeze it in right here. M in, M in. We have 3 oxygens. Each of those oxygens has a -2 charge. And if you add that up, 2 + 2 + 2, my total negative charge on this side from all my nonmetals is -6. I must have a +6 on this side. That's the only way it's going to be neutral. And that +6 must be distributed equally among these 2 manganese with a 3+ on each of them. And that's why I would do a +3 for my charge. Okay, our next one, potassium. MnO4 is permanganate. It's a polyatomic ion. No need for a Roman numeral. Potassium is a group 1 metal, always the same charge. Our next one is ammonium. That's a polyatomic ion. Nitrate. NO3 is also a polyatomic ion. Our next one is mercury. Hg is mercury. And then there's a 2 and a 2. And this is really rare to see this. These compounds are always written, ionic compounds, by these compounds I'm talking about, ionic compounds, they're always written with the lowest whole number ratio of elements. So this could be reduced to something like this, HgCl. It's not written that way because Hg2 is actually a polyatomic ion. If you go to your table, at the bottom of the table, you will find, oh, it's not on my table here, you will find below all of these guys a list of positive ions, and in that table you will find Hg2 as a form of mercury where each of the mercuries has a +1 charge, so this has a total of a +2 charge. And we call that mercury, mercury 1. Find that in your chart and you'll recognize why these have to stay together, because they're coming as a polyatomic ion as a pair to make that charge, and this is mercury 1 chloride. Okay. Our last one is chromium oxide, and chromium can have more than one charge. Chromium's in our D block, so we need to figure out our charge here. 3 oxygens, each with a -2 charge, will give me a total charge on this side of -6, just like we saw above. And the chromium has to equally distribute that to get a +6. So each of those chromiums must be a +3 charge. 2 times 3 gives me my 6. So this must be chromium 3 oxide. And there it is. On this side, we're going to go from the name to the formula. We have potassium chlorate, and we haven't done any of these yet. So here's what you want to do. I'm going to write my potassium symbol, and I'm going to look on my periodic table. You'll find that potassium is in group 1 on your periodic table. And group 1 has one valence electron, and when it loses it, it always makes a +1 charge. Chlorate is not ending in the ide. If this ended in IDE, this would just be chlorine, but because it ends in 8, I'm going to look on my polyatomic ions reference table and try to find chlorate. Chlorate is right here, ClO3 with a -1 charge. So ClO3 with a -1 charge. Well, potassium has a +1 charge, and these all work together to have a -1 charge, and +1 and -1 is neutral, so I just need one potassium and one chlorate, and I make a neutral compound. There's my formula. Let's do our next one. Sodium, Na, is also a group 1. It's a +1 charge. Chlorite, again, this is not IDE. IDE would mean we're attached to chlorine. So let's go to our polyatomic ions reference table again and look for chlorite. You'll find chlorite right above chlorate. Here it is. And chlorite is one less oxygen. And in general, for all polyatomic ions, the ite is one less oxygen than the 8 version of it. Right over here, sulfite, one less oxygen than the sulfate. And that's true for everything on your polyatomic ions reference table. And you can check that, but that's one way to help us understand. If we can remember chlorate, we can also remember chlorite, because it is the same formula with one less oxygen and the same charge. Well, we have a +1 and a -1, so for the same reasoning, we only need one of each to make this a neutral compound. There's our formula. Our next one, lead-2 nitrate. Lead is Pb, and it can have more than one charge. So it gave us the charge here. This is Pb with a 2+ charge. Nitrate is NO3. It's on your polyatomic ions reference table with a -1 charge. Well, if we're going to make this neutral, a +2 and a -1 does not add up to 0. So we need another nitrate. It looks like this. And one lead will attach to 2 of these to make a neutral compound. And to write that, we actually put the NO3 in parentheses to say this group of atoms, NO3, one nitrogen, 3 oxygens, will collectively work together to make a -1 charge, and we need 2 of these groups of atoms, 2 NO3s. And you need to do that with parentheses every time you have more than one polyatomic ion. Magnesium oxide is going to be Mg, and it's a 2+ charge, and oxygen is a 2- charge, and this becomes MgO. And I think we actually had that right here. Same compound. Okay, I hope that helps answer your questions on the note guide for the Your Turn ionic compounds.